Hello, everybody. So in the last presentation, we talked about what happens to the optimal bundle when your income changes. And today we're going to talk about what happens to the optimal bundle when the price of one of the goods on the graph changes. So in this scenario, we start with an income of $450. There are only two goods we can buy, burgers and milkshakes. Burgers are $11.25 per unit on the horizontal axis, and milkshakes are $15 per unit on the vertical axis. And initially, our optimal bundle is at the point of tangency between the budget constraint and our preferences at point A. So the question is, what happens to the optimal bundle if the price of burgers falls to $7.50 per unit? So I want you to take a second and figure out what the new intercepts for the budget constraint would be if the price of burgers falls. So I'll give you a second to think about that, and then we'll move on to the next slide. Or we will draw it on this slide. All right. So if the price of burgers falls to $7.50, we would be able to afford 60 units if we spend all of our money on burgers. The number of milkshakes we could buy would remain unchanged because the price of milkshakes hasn't changed at all. So our new budget constraint would be right here, which means that we would be able to get to a higher indifference curve right around here. So we would end up on a higher indifference curve, so we're better off, and we are consuming more burgers. So we've moved to the right, and it looks like we've moved up a little bit, so we're also consuming more milkshakes. All right. Next example. So here really the only thing you have to do is figure out what's happening to the budget constraint, and then you just draw on an indifference curve that is tangent to it. All right, so in the next one, I think one of the prices is going to go up. Putting new batteries in this pen has changed my life. Okay, what happens if the price of burgers rises to $22.50 per unit? Okay, so now I'll give you a second, figure out the intercepts of the budget constraint and put those in, and predict whether or not we're going to end up on a higher or lower indifference curve. Okay, so if I spend all of my $450 on burgers, I can now only afford 20 burgers. So right here, again, the price of burgers doesn't affect how many milkshakes I could buy if I spend all my money on milkshakes, so we're still at the same y-intercept. So now my budget constraint looks like this, and the indifference curve that is tangent to that budget constraint might look something like this. So that would be the new optimal bundle. So we would be worse off because we're on a lower indifference curve. So that's what that would look like. Without equations, you can't find the exact point, the exact coordinates of the new optimal bundle. So right now we're just looking at graphically. I wouldn't ask you to give the specific numbers of how many burgers and milkshakes you are consuming at the new bundle with just this information given. You'd have to be given some information about what the utility function looks like. Okay, so this one show what happens if the price of milkshakes drops to $11.50. I want you to go ahead and figure out the new intercepts for the budget constraint and predict whether or not we are going to be on a higher or lower indifference curve. All right. So if I spend all my money on milkshakes, I can afford almost 40 milkshakes. The amount of burgers I can afford hasn't changed. So here's my new budget constraint. We have to end up on a higher indifference curve because price went down. So we might end up something like this. Okay. So this would be point B. We are better off. Anytime prices go down, we're going to be better off. Okay. All right. So when we were looking at those shifts, there's actually two different effects going on when we have a price change that contribute to the overall change in our consumption. So the first change we're going to look at is that when one of the prices changes, the slope of the budget constraint changes. And in when we were looking at how to find optimal bundles algebraically, we saw that at the point of tangency, the slope of the budget line and the slope of the indifference curve have to be equal. Do you remember the slope of budget line is the price of the horizontal good divided by the price of the vertical good, so px over py. That has to be equal to the marginal rate of substitution. When one of the prices changes, it changes the slope of the budget constraint, which we just saw in the previous examples. So that means that in some way, if the slope of the budget constraint changed, oh god, that was a terrible draw. So let's say it got steeper, the budget constraint got steeper. If we were going to stay on the same indifference curve, we would still shift along that indifference curve to a different point. So the combination of good X and good Y that we would consume would change in response to the price change. Because the slope of the budget constraint changed, when the price changed, the slope at the point of tangency would be different. So we'd have to move along the indifference curve to some other point that would match the new ratio of prices. So, if the budget constraint shifted like this, and we were going to stay on the same indifference curve, we would have to shift to a new position. So one of the responses people have to changing prices is that they alter the optimal combination of goods that they would consume, even if they were going to be on the same budget constraint. So, and typically you are going to substitute or move along the indifference curve towards the good that just got cheaper. So that makes sense if you're buying two goods and the price of one of them goes down. You're going to substitute towards that good to consume more of it because that's going to increase your utility. The utility per dollar spent on that good just got better, so you're going to move more towards that good. This portion, when you're changing the mixture, what on earth is that noise?
Save big on America's best-selling SUV.
Silence. Good God. Sorry about that. Anyway, so this effect, after price change of just altering the combination of the two goods you're using towards the cheaper one, is called the substitution effect. Okay, the second effect that's happening is when a price changes, it actually affects your buying power. So you can think of price changes as affecting, in some ways, your real income or what you can afford to buy with your income. So even if your income doesn't change on paper, so let's say you're still making $400 income, when prices change, it's going to affect how much you can actually buy with that $400. So if the price of one of the goods goes down, your buying power has actually increased. You can afford more. Imagine that if your income stayed the same, but prices of everything dropped by half, you would then be able to afford twice as much as you were before. So another way in which price changes affect the optimal bundles, let's say we started here, and let's say the price of the price of good X went down, we can get to, we don't have to stay on the same indifference curve. We can get to a higher one. So the shift over it reflects the change or the increase in our buying power. The opposite is true. If a price goes up, it reduces your buying power and you end up shifting over. So the change in the amount of goods that you buy that is due to buying power changes is called the income effect. And in a second, we're going to look at how we can identify the size of those two effects on a graph. All right, so put this in your notes. Okay, so this is a diagram of how we can find the size of the income and substitution effects on a graph. So this is looking at one of the situations that we did earlier where the price of burgers goes up to $22.50. So initially we were at point A, the red dot. Excuse me. So we start here at point A, and then the price of burgers goes up to $22.50. So that sets a new slope, a new steeper slope for the budget constraint. And we already did this earlier. You draw the new budget constraint here. So to identify the size of the substitution effect for burgers, what we're going to do is we take the new budget constraint and we draw it so it's tangent to the original indifference curve. So that's the dotted blue line here. We took the new budget constraint with the new steeper slope and we drew it so that it's tangent to the original indifference curve. So this is like doing the experiment of, we're going to change the price, but we're going to keep you we want to keep you equally happy as you were before prices changed. So we're going to keep you on the same indifference curve, but we're going to move you to a new point of tangency where the slope of the indifference curve is equal to the new ratio of prices. So as you can see, we end up moving to the left from point A to point A prime. That changed from A to A prime, so it looks like about 5 burgers worth. So if you look, I was at 30 burgers, and now it looks like I'm at 25 burgers. So that negative 5 burgers, that's the substitution effect. Burgers got more expensive, so I'm going to move away from burgers and towards milkshakes to stay equally happy. The rest, so in reality, we ended up at point B. So we saw earlier, when we did this example, that we ended up at point B as the final equilibrium point. The rest of the movement from 25 burgers down to, it looks like 15 burgers, so that's a change in 10 burgers, that was the income effect. So the rest of the reduction in burgers that I ate came because my buying power went down. So the first, well, you can think about it as the first five burger reduction. That was a substitution effect. And then the rest of the reduction was due to the income effect. Okay, some key vocabulary. So for normal goods, so remember, I'm going to put a play pause question to make you remember what normal goods are. Normal goods are goods where when your income goes up, you buy more of it. So for normal goods, substitution income effects always work in the same direction. If price goes up, they're both going to make you reduce. Oh, I'm out of time. We'll wrap this up in class. Talk to you later.